Welcome class. Today we will dive into Class 9 of NCERT Chapter-1, Orienting Yourself, the use of coordinates. Let us begin. What are coordinates? A coordinate is a way to represent the physical location of an object. What does it mean? Let us take an example. We have seen latitudes and longitudes on a globe, right? So these latitudes and longitudes are used to identify specific places on the globe or on the earth. So which means they are nothing but the coordinates of that place. One more example. If you have watched Avengers Endgame, do you remember? Ant-Man tells them how to navigate through quantum realm. He says, you have to enter a specific point in quantum realm and exit at some other point. These are nothing but space-time coordinates. Here time is also a coordinate, and these coordinates are also used to locate the planetary objects like star, a city on earth, or the distances between the stars and galaxies and all. So this entire thing comes under a coordinate system, and specifically in our Bharat, people have used these coordinate systems since the Sindhu-Saraswati civilization as well to navigate to navigate the local geographies. Now, how do you define your physical coordinates? Let us get there with this following example, okay? Suppose you are at a coffee shop and your friend called you to meet and he's at the library. How do you tell your location to him? This is you and this is your friend. Now you have to tell your location to him. So this location is always relative, which means you have to tell your position with respect to something, with respect to a reference point. So now you have to tell your location with respect to your friend's location, which is this library. So what do you tell him? From here you walk forward till you see a hardware store. Then at the hardware store you take a left and walk 4 blocks, and then you will see the coffee shop on the right, and for confirmation there is a bus stop on the left. This is how you tell him, right? Now let us see what we have used. Here we needed a reference point from where to start. This is a reference point, and so since we are viewing it from the top view, we needed 2 lines. One is the vertical line, this is the vertical line, and a horizontal line. Okay, remember these, we will come to these. You might have studied integers and how to represent them on a number line, right, from your earlier classes. Here we use the same number lines but in 2 perpendicular directions, okay, which means they intersect at 90 degrees at the origin or 0. Okay, so we'll just turn this 90 degrees. This will be 90, and the numbers will be the same: 0, 1, 2, 3, 4, and -1, -2, -3. Now this is nothing but a 2D plane. Yeah, the 2D Cartesian coordinate system. Now this is what a 2D graph looks like. The 2 perpendicular lines which meet at 90 degrees. And now we will get into some technical stuff. Okay, all the things which we have discussed have actually proper names. Now we will just go through those names. Okay, this reference point is called origin, and the horizontal line which we have used, this is called x-axis, and the vertical line is called y-axis. Okay, these two are the perpendicular axes in a 2D plane, and the point where that these 2 lines intersect is called the origin. Okay, And this entire sheet or this entire graph or the whiteboard or the surface which you draw, this entire thing is called a plane. Now this has two axes, so this is a two-dimensional plane or a 2D plane, and it is also called as Cartesian plane or coordinate plane or just XY plane. You can call it whatever you want. Now let us imagine a point P of x comma y. This is how we represent a point. This x is the x coordinate. The x is the x coordinate and y is the y coordinate. Now we will project this point onto the x axis and y axis. Okay, this is perpendicular projection. Now this x is the x distance of this point from y axis, and this y is the y coordinate, which is the distance from x axis. So this is how we represent a point in 2D space. Okay, now let us calculate the distance between 2 points if they are lying on the same axis. For example, the point lies here on x-axis, P of x1 comma 0. Since the point lying on x-axis, the y coordinate is 0, and Q is x2 comma 0. Both are lying on x-axis. And now how do you calculate the distance? This distance we know x1 and this distance is x2. The difference of this will give the distance between the 2 points, which is x1 minus x2. And since distances are always positive, so if you do x1 minus x2 and x2 minus x1, both should be same, so you will just put a modulus. The distance is positive and this distance is nothing but pq. So if the point lies on x-axis, the distance is mod of x2 minus x1, which is the difference between the x coordinates. And in the same way, the points lie on y-axis, the distance between them would be, so first these points will be 0 comma y2 and 0 comma y1. The distance between them will be y2 minus y1 mod. Okay, that's how we calculate the distance between 2 points. We'll go to exercise 1.1. So this is exercise 1.1 from the NCERT textbook. Now we will solve this. Okay, we are given a figure is a bedroom, and here the scale is 1 centimeter is equal to 1 foot. Okay, that means here whatever you see, the distance is here, it is represented on a graph, and here normally on a graph each block will be 1 centimeter. In real life the scale is, we have to mention the scale always. Okay, like on the graph, if 1 centimeter is equal to 1 foot in real life, that's how you write a scale. Okay, this is always important. And now we can see this is the origin point, and from here this is x-axis and this is y-axis. Here we are given a bedroom of a student Rayan, and we have to answer the questions based on the given figure. So let's go to the first question. Always remember, don't panic when the question is big. Okay, if the question is big, just remember they are giving too much information, and if they give too much information, it is really easy to solve. That's how you approach the problem, always with that mindset. So now coming to the problem, if D1 R1 represents the door to Ryan's room, here if you see, this is D1 and this is R1. Yeah, so now this and this is the length of the door, represents the door to the Ryan's room, D1 R1. How far is the door from the left wall, the y-axis? Okay, so this is the y-axis here, this is the y-axis, and we have to find this distance. So the first point where the door is visible is D1, right? So we have to find this distance. So this is y-axis, and this we have to find this distance. So first we will write the coordinates of d1 and in the form of x comma y. Okay, so this is d1. It lies on x-axis, which means the y coordinates are 0. And what is d1? Here where did the point start? It started at 8, so that will be the x coordinate. And where is the second point? It's somewhere around 11.5. We will figure it out later. But the closest point to the door is the closest point of the door to the y-axis is d1, so which will be 8, 0. So which means this distance is 8 units. Or in real life, if the scale is 1 centimeter equal to 1 foot, it's 8 feet. 8 feet. Okay, from the y-axis. That's the first answer. How far is the door from the x-axis? This is x-axis. The door lies on x-axis, which means the distance will be 0 feet. That's the first question. Okay, so simple. We'll go to the next one. What are the coordinates of d1? As we have already solved, this is d1. If you were not clear, I'll explain it again. So the point lies on x-axis, which means the y coordinate is always 0. And now what is the x coordinate? The distance from y-axis, which means this distance, which is obviously we can see that here it's 8 units. And what's the what if r is the point 11.5, 0? See, that's what we got. But this is not always right, because here we can directly see they have mentioned d1 here at d1 is at 8, but here we cannot see the number exactly, but it somewhere lies between 11 and 12. If they did not mention it clearly, we should not assume. Okay, if r is a point 11.5, 0, how wide is the door? Okay, so the door, it's 11.5, 0 and d1. Okay, well, suppose 2 points lie on the same axis, which means the y coordinates are 0 here. What did I tell you? It's just x1 minus x2 modulus, which means 8 minus 11.5, which is 2.5. Here the signs doesn't matter, because we are measuring the length, just length. Okay, distances or the length in real life cannot be negative, which means the distance from here to here is 2.5 feet. Okay, and some more of it. Do you think this is a comfortable width for a room door? 2.5 feet, I think, may be enough to fit in a person through that door, but I don't think it's not that comfortable. And if you see the next question, if a person in a wheelchair wants to enter the room, will he or she be able to do it easily? Normally, I don't think. Generally, a wheelchair might be roughly around 3 feet, so I don't think that is like a good distance for a door width. But we are not sure. It's actually dependent on the wheelchair. And what's the next question? It's b1 is 0, 1.5 and b2 is, so where are b1 and b2? They are here. Okay, b1 is here, which is 0, 1.5, and b2 0, 4. This is a bathroom door, represents the ends of bathroom. The bathroom door narrower or bit wider than the room door. So what did I tell you how to find the distances between 2 points on the same axis or on the same line? Here on the same axis. So the x coordinates are obviously 0. So what is the distance? 4 minus 1.5 mod, which is 2.5. 2.5 units or 2.5 feet. To be specific, here we are given feet, so it's feet, 2.5 feet. This was also 2.5 feet. Now is it narrower or wider? It's the same. What Cartesian quadrants are. So this is x-axis and this is y-axis, right? These two axes divides the plane into 4 parts, which are called quadrants. So this is Q1, Q2, Q3 and Q4. These are the 4 quadrants, okay? And you need to know the properties of these 4 quadrants. Let us assume a point P of x comma in quadrant 1. What can you say about it? You can see that the x-axis will be always positive in this quadrant and also the y-axis, which means the points are always positive. The numbers are always positive in the quadrant 1. Similarly, if you come to Q2, the x-axis is negative here, so and the y-axis is positive, so it is minus and plus. Okay, and similarly in Q3 the x-axis is negative and both the y-axis is also negative, and in Q4 x is positive and y is negative. So you need to remember the properties of each quadrant. Yeah, we will start exercise 1.2. So given that we have given on a graph sheet, mark the x-axis and y-axis on the origin. So yeah, here it is, table. This is 8, 9, 11, 9, 11, 7, this is 11, 9, this is 11, 7, so the table is gonna be here. Do you think this is the right spot for a table? I don't think so. Let us put it to one side of the wall, that would be better. What is the width of the table? The length. Can you make out the height of the table? So now this is a table, right? The longer side is the length and smaller side is the width. This is 8, 7 and this is 11, 7 and this is 8, 9, this is 11, 9. Now what is the length? The y coordinates are same. That means 11 minus 8 mod of 11 minus 8, which is 3. Similarly, the width of the table, the x coordinate is same, so 9 minus 7, it's 2. So the length is 3 and width is 2. And can we make the height of the table? Is it possible? Because we are looking at the top view, we cannot see the height of the table. Okay, it's only 2D. If you want to also calculate the height, then that comes under 3D geometry. You will learn it in 3D planes, 3D Cartesian planes. Okay, now let us see the second question. If the bathroom door has a hinge at B1, which means the hinge is at B1 and opens into the bedroom, if it opens like this, will it hit the wardrobe? We have to check that. Okay, suppose if we imagine this door opens like this, somewhere B2, we do not know whether this will be here or here. Okay, but when it, so what is the length of B2, B1 to B2? It's 1, 2, 3. This is, we obtained this in exercise 1. This is 2.5, right? So if we extend this here, this is gonna be 2.5, which means it's gonna be still here till here. So we can say that the bathroom door does not touch the wardrobe. The next question, what are the coordinates of OFRP of the bathroom? So we want to know this 4 coordinates. This is O origin, and what is P? It lies on x-axis, which means the y coordinate is 0 and it stays at -6. And what is R? It's at the same distance of P, right? It is still parallel. This line is parallel to y-axis, which means the x coordinate is the same, which means -6. What is the y coordinate? The distance from x-axis. So we can see here, this is the line, same line, right? What is this? 9. So this is gonna be 9.